Hello, welcome back to our AI engineering crash course. This is the second video of the fourth module where we'll be talking about vector databases and semantic search. In the first part of this module, we talk about embedding. We explain a bit what embedding is and how you can use them and why they actually exist. In this part of the video, I will give you some embedding providers, some vector store providers, and show you how to do semantic search and how to query data from a vector store. Okay, so let's get started. From this last part, we stopped here, right? The good thing is that you don't have to deal with the model. You don't have to train a model. You don't have to implement the word logic. It's actually pretty hard to do everything. So what you need to do is just use vector store, use embedding models, and compute the embedding and save them in a vector store that you'll be using later for your AI application. Okay. And as in the last module, we presented multiple providers. You can see that these providers actually support a lot of vector store. Okay, if I do Langchain vector store, it choose this one. Okay, you will see that here we have a really long list of vector stores. Okay, all vector stores, you have all of these vector store. So these are like databases for your embeddings. So it means when you calculate the embedding using models that actually exist, like OpenAI embeddings model or Entropy model or Google model, you save them in this database and the whole process is simplified by Langchain. If you want to do it yourself, you can actually code that. It's not really an issue. But if you want to go fast, you can use the Langchain or the Haystack or the Llama Index ecosystem to go fast when it comes to embedding your document and working with document in general. So let's say you choose ChromaDB. ChromaDB is actually just, you can choose it online like this. It's just a startup. Here, open source AI application databases. So as I mentioned, it's saving your data and retrieving it based on your query. Okay. Same for many of these providers. You have Typecone as well. You have, I think you have somewhere here, Wave8 as well. In Fires as well. But we'll be using the in-memory vector store. It's actually the same thing. Nothing will change when you switch from in-memory vector store to Chroma or other providers. So we'll be using this only for example purposes. Okay. So if you want to see the complete list of provider, this link is the best way. It's the best results. You can do the same with Llama Index vector store, vector databases. So, and here normally I think you need to go to the hub. Okay, Llama Index hub, and you look for vector store. You will see all the providers here. DTB, Redis vector store, even MongoDB. You can save your embeddings into MongoDB, same as Postgres. If I'm not wrong, you can do the same with Postgres already. Postgres support vector store already. And you can also use one of these new providers like Wave8 or Pinecone. I think we should have Pinecone here. Pinecone or Elasticsearch Store. So you're free to choose here. And as I mentioned, these are actually abstraction layers. So you can switch from one provider to another pretty quickly by installing it and just calling it. Okay. Same here. So if you want to use ClickHouse instead, you'll just see that you install the ClickHouse module and then you initiate your embedding module and you pass it to your vector store module. When the vector store is ready, it's just chained with other tools. So it's fine. You can change this ClickHouse to some other provider later. It's fine. You will not have to change your whole application logic. So with that said, we have all of these providers. We'll just be using the in-memory vector store. And let's just go through a sample example where we'll actually put the document that we had in the last module in some vector store and query it. Okay, let's get started. Okay, you can see that we stopped here last time. Let's go in the Langchain version. You'll see that we have documents here, right? But we are doing nothing with it. We are just concatenating it and then adding it to the prompt and then sending it to the AI. And if you see, we had some place here, the whole document, which is really long, right? We don't want to do that. So what do we need to do? We can create a folder here called rag, and we'll just create a Langchain memory.py. And in this file, we'll actually put all the logic to save the documents that we have here, the startup document, into the vector store and retrieve it. Okay. So to do that, we need to, of course, as usual, import our modules, right? So we do this, we import all our modules. Here you have the document, the PDF loader. We talk about it. The new thing here is the in-memory vector store. And this in-memory vector store can be replaced by ChromaDB or whatever. It's just a database for your embeddings, a database for your numerical representation of the text that you'll be giving to the AI. OpenAI embedding is the embedding module from OpenAI that will be calculating this numerical representation of the text that will be feeding to the model. Okay. So now, as usual, the first thing is to load the M variables so that the AI can use it, right? And then we initialize our vector store. This is how we do that. Pretty simple. In memory vector store, we pass our provider here, the OpenAI provider, and then we have the vector store ready. Okay. Now we do the same code that we had here with Langchain, this exact code here to load the PDF. We do it here. We load our PDF. We need to change here to okay. It will go in the PDF. I think no, we can just directly run it this way. If I'm not wrong. Yeah, we'll see. We have all the documents here, right? All our documents. You can just first print it again. Print documents so you can see that it's actually split. So if you do Python rag and then Langchain, you have all our documents here. Okay, and maybe let me drag it like this. It's an array of documents. Document with values and yeah, and with metadata as well, like the source, the file, the total pages, the actual page, and other. So that's fine. Now, how do we do to, let me just grab this down, to save it? Pretty simple. You'll see how simple is it. So we just do this, vector store.add documents. So our documents that this PDF will be saved in our vector store as numbers. Okay. Okay. So with that said, when we'll do this document here, we can actually just do maybe I can. If we run this again, maybe we will not see the thing, but it will save this document in the memory. Okay. I don't know if we print the vector store, we'll get something out of it, but let's see. It's just an instance of the vector store. So now, how do we do to make some search on it? It's pretty simple as well. We just call the function similarity search. So everything is simplified with the framework. That's the reason why you need to avoid coding everything from scratch. You do something like this, vector store dot similarity search, and then we print the result. Okay. It will actually go through the documents that we have. Oh, it's results that we have, and try to find the sections where we are talking about AI agents and print it. Okay. So here you'll see that this is less than last time. I asked for 2 documents. I can ask for 1 only, and you'll see that it's even smaller than what we have right now. So this is smaller than this, right? So it went through the list of documents and extracted this document here with this content. What is it again? Page content. Language model can already code better than humans. Yeah. So you will see that in terms of sense, everything is actually close, but this is close to, we're talking about AI agents and things. And you can change and be like, okay, I don't know, infrastructure and I don't know, aviation. It will find the thing that is closer to this and send it back to you. So if you search it again, we'll get a different document. Idea appear when you're reading ECL book. App Store is an app store where you will be, okay, you see, we support the infrastructure needed for AI progress, hyperscale data center projects, and you'll see that we have some terms here that are close to the infrastructure term, right? Same. So what we can do now is instead of passing all these to the AI, all the word PDF to the AI, we just pass this, okay? And the AI will extract the answer directly from this. If we ask, give me the ideas that are related to infrastructure, and we get the 2 or 3 first documents, the AI will summarize it and use it as context to actually answer your question. Okay, so I think that's enough for this part of the video. And in the next part of the video, we'll actually talk about real retrieval augmented generation on real documents using Langchain. Okay, thank you for watching and see you in the next one.